Alright, so we talked last week first about reviewing naming for acids and bases, and then the basic properties of acids and bases. So, in a few words, what is an acid? What does an acid do? Donates protons. Okay. So acids donate protons, and protons are equivalent to hydrogen ions. The amount of protons is equivalent to the amount of hydronium, okay, because protons react with water to make hydronium. So then, we talked about some things that could act as either an acid or a base. So water is an example of that. And so if I ask you, what is water, an acid or a base, can you just answer that question? No. How do you figure out, for any given situation, if water is an acid or a base? Look at whether it gives or receives, but what determines that? Yeah, the other thing, what is being reacted with. So water does something else. So water also, in addition to acting as an acid or a base, what do we call that, by the way? Something that can be either an acid or a base is amphoteric. Okay. So in addition to being amphoteric, water does what we call self-ionization. So what is ionization? And it breaks apart to make ions. Okay. So water does that. So if we have H2O liquid, we get H plus AQ plus OH minus AQ. So if the H plus is aqueous, that means it's dissolved in water, correct? So what does a proton react with water to form? What is the result of that reaction? Hydronium. So I can say H3O plus right there. I can substitute those out. Because H plus is going to react with the water to make H3O plus. So that's a reaction. I drew it with reversible arrows, so we have some sort of equilibrium. So could I write an equilibrium expression for this reaction? Yeah, so go ahead and do it. And I'll include H3O plus instead of H plus. Is water in the denominator? No. Why not? Liquid. Okay. So if concentration of hydroxide times H3O plus concentration equals K, what is K? What's the name for K? Equilibrium constant. So I can say the product of H3O plus and OH minus is a constant. So it turns out it's a number that we know is equal to 1.0 times 10 to the negative 14th. So 1.0 times 10 to the negative 14th equals hydronium times hydroxide. So if this times this is always 1.0 times 10 to the negative 14th, if hydroxide increases, hydronium has to do what? Decrease. So when one goes up, if one goes down, what type of relationship is that? Inverse. So let's think for a second about why that is an inverse relationship. So let's look at H plus. Let's say I increase the amount of H plus. What donates H pluses? Acids or bases? Acids. So if I added an acid to the solution, I would increase H plus, right? Because it would donate H pluses. So if I increase the amount of H plus, will I shift equilibrium to the left or to the right? The left. So if I shift to the left, does that increase or decrease the amount of hydroxide present? Decrease. So does that match what we said? If one increases, the other has to decrease. So that's kind of the reason why it's Le Chatelier's principle. But it's important to note at 25 degrees Celsius. That number is only true at 25 degrees Celsius. What is 25 degrees Celsius? Pretty close to room temperature, so why we choose that value. So why would the number change if you were not at a certain temperature? Yeah, temperature affects equilibrium. So to know if the number is going to increase or decrease, what do I have to know about the reaction? Endo or exo. So this particular reaction is endo. So I can do plus energy on the reactant side. So if I increase temperature, so I add energy, would I shift equilibrium to the left or the right? The right. So what would that do to both of these concentrations, up or down? Up. So if I increase both of these numbers, will the value for K change? Yes. So there is a different K value for this reaction, the ionization of water, for every temperature. In this class, we'll only do problems that are at 25 degrees Celsius. None of the questions will say that they are, but we assume that they are. If you take chemistry next year and years to come, you'll look at when they're not at 25 degrees Celsius. Okay? So now, with this equation, and knowing the value for K, if I know the concentration for either hydronium or hydroxide, can I solve for the other one? Yeah, hopefully. Let's look at a few examples. So the first one is a 1.0 times 10 to the negative 4 molar solution of, what's the chemical? The words. Nitric acid, that's one you got to know. Calculate the H3O plus and the OH minus. So first, what is nitric acid going to do when it's added to water to make a solution? What do acids do in water? They don't dissociate, they ionize. So I can say HNO3. So what was the adjective I have to describe an acid that completely ionizes 100%? Strong. Okay. So we're going to assume for now that all our acids are strong, that they are going to completely ionize. So that means every single HNO3 becomes 1 H plus and 1 nitrate. So if I have 1 mole of nitric acid, how many moles of protons does that produce? It's 1, right? So every nitric acid makes 1 of these and 1 of those. So if the concentration of nitric acid is this, 1.0 times 10 to the negative 4, what is the concentration of H pluses? Yeah, 1.0 times 10 to the negative 4. Because every HNO3 makes 1 H plus. So we said that the amount of H plus is equivalent to what? The amount of H3O plus. So now, with doing no calculations, can I answer the concentration of H3O plus? Yeah. So concentration of H3O plus equals 1.0 times 10 to the negative 4th molar. So that was easy enough. Now, can I plug in the formula and solve for the concentration of hydroxide? Yeah. So I can say 1.0 times 10 to the negative 14 equals 1.0 times 10 to the negative 4 times the concentration of hydroxide. So I know you can do it in your head, but go ahead and type it in the calculator to make sure you can type it in correctly. It's easier to practice typing on an easy example. That way when we do ones you can't do in your head, we know you get it right. So what's the answer going to be? We should know it. Do we agree? Maybe we should use calculator. Type it in, see what you get. We agree with the negative 10?
I got 1. I got 1 minus 10 to the negative
You should get times 10 to the negative 10. If you aren't getting that, use parentheses. So this number divided by that number. This divided by that. You're solving for a concentration of hydroxide. So how can I check myself easily? You multiply those two answers together, and they should equal what? Yeah. Hydroxide times hydronium always equals 1 times 10 to the negative 14. So if you want to check your work, just multiply them together. Not too bad, right? Let's look at the next one. Given a 1.0 times 10 to the negative 2, what does brackets mean? Concentration. So molarity of sodium hydroxide, calculate the H3O plus concentration. So what is sodium hydroxide? Acid or base? Base. So bases do not ionize in water. Metal hydroxides do what in water? Dissociate. So I have NaOH becomes Na plus OH. Now what determines whether or not that's going to dissociate? Solubility. So we can check the solubility table. It's soluble, so we're in good shape. So now 1 mole of NaOH makes 1 mole of what? Hydroxide. Okay. So can I automatically know the H3O plus concentration? No, but what can I know already? The hydroxide concentration. So that equals 1.0 times 10 to the negative 2 molar. Is that the answer? But is that useful information? Yes. Now can I plug into the formula and solve for hydronium? Yeah, let's go into it. 1.0 times 10 to the negative 14th equals H3O plus times 1.0 times 10 to the negative 2. So what's the answer? 10 to the negative 12 molar. Yes?
I don't get why we're solving for hydronium when it's not in the equation.
So we'll talk about it in just a second. That's a good question. Now, questions on just getting the number answer. So let's look at why this does this. So sodium hydroxide is going to do what, or produce what, when it dissolves in water? Sodium hydroxide. I don't care about sodium hydroxide though. Okay. So water on its own does this reaction. Okay. So all water that we have, to some extent, ionizes. It breaks apart into H plus OH minus. Okay. So when I add the OH minus from the sodium hydroxide, it increases OH minus. So that shifts equilibrium what direction? To the left. So if it shifts equilibrium to the left, what does that do to the H3O plus concentration? It goes down. Okay. So whatever we're changing just affects this equilibrium up here that already happens with the water. Okay. Does that make sense? Then we're going to use that in a minute to calculate pH. That's why we really care about this. Okay. So how can I check my work here? That times that has to equal 1 times 10 to the negative 14. Okay. So I solved for different things initially. On one, I solved for H3O plus first. On the second one, I solved for hydroxide first. Why were those two problems different in how I did it? I was given a what versus a what? Yeah, an acid versus a base. Okay. So acids will produce H3O plus. Bases will produce hydroxide there. Okay. Let's look at the third one. Given a 1.0 times 10 to the negative 4th sample of, what's that molecule called? Sulfuric acid. Calculate the hydroxide. So will it ionize or dissociate? Ionize. Let's write the formula. H2SO4 What's wrong with what I just wrote? and a 2 there. If you take chemistry in the future, you'll learn this isn't quite what happens. It doesn't quite fully dissociate, or excuse me, fully ionize, but we're going to assume for now that it does. So, back at number 1, I said that 1 mole of acid produces 1 mole of H+. For this one, 1 mole of acid produces how many moles of H+? 2. So can I say the concentration of acid is equal to the concentration of H3O+? No. What must I do to the concentration of the acid? Multiply by 2. So concentration of H3O+ equals 2.0. That's just because every one H2SO4 makes 2 H pluses, or 2 H3O pluses. So now can I plug in and solve for the concentration of hydroxide? Yes, so go ahead and do that. So why was 3 different than 1? Well, what's the word I use to describe an acid with 2 hydrogens? No. Diprotic. So diprotic has 2 protons. Yes?
Why is it written as 2H, not like H2 as substrate?
So it's not diatomic, it's an ion. So like F minus can just be F minus. So if there's ions, the diatomic rule does not apply. Okay. Questions on that? So go ahead and try the last one. So 2 answers, H3O plus and hydroxide. So I give you an acid, so what are we going to figure out first? H3O plus or OH minus? H3O plus. So what's the answer for the concentration of hydronium? Is that an easy one? Yeah. It's just 2.75 times 10 to the negative third molar. Then I calculate the hydroxide concentration. So we should get 3.64 times 10 to the negative 12th molar. And if I wanted to check, multiply those 2 answers together, and they should come out to 10 to the negative 14. Yes?
So, the hydronium is like double of the original? Or?
No, because HNO3 only makes 1 H. So it's just the same as the given number. It was doubled here because H2SO4 has 2 hydrogens to donate. So there's a note at the bottom with some stars beside it. It says for this class we're going to assume that the concentration of acid equals the concentration of H plus for a monoprotic acid. Why is that not really always true? And then when is it actually true? In what situation is that statement true? Concentration of acid equals concentration of H plus. If the acid is what? Well, we say monoprotic, but what other requirement must be true about the acid? It's got to be to be true for the acid to give away all its protons? Yeah, strong. Okay. So by definition, if it's strong, the amount of acid is going to equal the amount of protons. If it's not strong, it does not fully ionize. So if it doesn't fully ionize, does the amount of acid equal the amount of protons donated? No. So this calculation is a little more complicated if it's weak. We're going to pretend for now that they're all strong for these calculations. Okay? So now, we did all that just to do this. So what do we know about the pH scale so far? What's the typical range we see? Typically 1 to 14. It's really not just 1 to 14, but for this class it will be. 7 we consider to be neutral. Below 7 is acidic. Below 7 is acidic. Above 7 is basic. So we can think about it in terms of a measure of acidity. The lower the number, the more acidic it is. The higher the number, the less acidic it is. So we have a formula, pH. So typically in science, P of some variable refers to the negative log of that. So that equals the negative log. So if I write a log with no base, I'm assuming the base is 10. So if you want to write log base 10, you can, but I'm not going to. These will all be log 10s of H3O plus, which is equivalent to protons or hydrogen ions. So then, everybody else will struggle with this for some reason today. If I want to rearrange and solve for H3O plus, how do I solve this expression for H3O plus? Hydronium equals, so you can't do pH divided by negative log. Negative log is not a thing. You take the negative log of something. So it's not a simple algebra expression.
Yeah, I hear what you're saying.
Okay.
Natural log.
No, it's not. Natural log is just a log with the base of E.
That's exactly what I said.
Have y'all done logs in math?
Yeah, I didn't know.
I didn't like
Okay.
I didn't say negative.
Alright, so if that's a basic math fact to you, then don't write it down. If that's new information to you, you better copy it down. That is just simply how you rearrange this formula to solve for H3O plus. We can talk about it later if you don't know why. So now if I know the pH, can I then solve for the hydronium concentration? Yes. And if I have the hydronium concentration, can I solve for the hydroxide concentration? Yeah. And all these calculations hinge on the fact that we're in an aqueous solution, which we will be for this class. Everything's going to be in a water solution. So then, if pH is the measure of how acidic something is, we have another function called the pOH. So if pH is a measure of how acidic, pOH is a measure of how basic. The pOH equals the negative log of hydroxide concentration. So then hydroxide concentration equals 10 to the negative pOH. We don't talk about pOH a ton because it's somewhat confusing. Because a low pH means that it is more acidic. A low pOH means it's more basic. So they're kind of opposite. We don't talk about pOH just a ton. But we do know that 10 to the negative 14th, we'll just say 1.0 times, equals concentration of H3O plus times concentration of OH minus. So using this that I know is true, can I come up with an equation to relate pH and pOH? So when you add them together, are they equal? Is it -3? What's the expression there? Or when you multiply them? Think about how you can rearrange this or solve this to include pH and pOH.
Yeah, just if you
Yeah, instead of
Okay, so let's think about this. So in math, can you add or subtract anything you want to as long as you do it to both sides? Yeah. Can you divide or multiply anything you want to as long as you do it to both sides? Right? So we're pretty much allowed to do whatever we want to as long as we uniformly do it, right? So if we take the negative log of each piece, the negative log of this number is going to be what? 14. So then, when I take the negative log of these two pieces, it comes out to pH and POH. We know that relationship. But they're no longer multiplied. When you have two things multiplied, this is the argument of the logarithm, what do they become afterwards? They're no longer multiplied, they're being added. So I have 4. So 14 equals pH plus POH. Is that new information to you? Okay, well, you learned something today.
We could probably solve it out.
So now we have several formulas that relate hydroxide concentration, hydronium concentration, H3O plus concentration, hydroxide concentration. So let's think about this for a minute. If I give you pH, can you now solve for concentration of H3O plus or concentration of hydroxide? If you have a concentration with units of molarity, can you solve for number of moles? Yeah. And then if you have a number of moles, can you do stoichiometry? So you probably see where this train's headed in a couple of days. Okay? But for now, let's look at some examples of where we use this. So a simple example, let's say I have 0.001 molar HCl. So first step for any problem we ever do, just ask yourself, am I given an acid or a base? And the answer is acid. So are acids going to produce hydroxides or H pluses? H pluses. H pluses correlate to hydronium. So the concentration of H3O plus equals what? 0.001. Because we assume that one hydrochloric acid makes one proton, because hydrochloric acid is a strong acid. Then, can I calculate the pH of this solution using this formula? Yeah, so what's the negative log base 10 of 0.001? You don't need a calculator. Maybe you do now. It's 3. Feel free to type in the negative. When I type it in, I always leave the negative off. Your answer will always come out as negative, and that negative just cancels it. So if you want to drop that off, you can to write the positive version of that. Okay? So then, using this formula, what is the POH? 11. So let's stop and think, make sure this is logical so far. Should this solution of hydrochloric acid be acidic, basic, or neutral? It should be acidic, right? Is a pH of 3 acidic? Yeah, so we're on the right track. Okay. Can I now calculate the hydroxide concentration? Yeah. So now I have two ways, right? I can use this formula or that formula. Will I get the same answer either way? Yeah. I can use this number and this formula, or I can use this number and that formula. So what's it going to be? 10 to the negative 11. And pH has no units, by the way. It's just a number. So now, what we're going to do next is all the stuff we talked about the last couple of days with the chemical reactions and conjugate acids and conjugate bases. Bring that together with this and solve some problems. Before we can do that, though, you have to learn these formulas. Must you memorize all of them? Well, if you can't use one to solve for the other, then yes, that's one route. Okay. All you really have to know is pH, the negative log of H3O plus, POH is negative log of OH minus, then this. So 1, 2, 3. The other three formulas are just solved for using those other three. If that's Greek to you, then I guess you could learn those formulas. Okay? So it would be in your best interest before tomorrow to learn those formulas. It will make solving the problems much easier.